So we are in Statistical Rethinking, second edition. We're in chapter 12 and we're starting the medium questions. So we'll do 12M1 and 12M2. Okay, so for 12M1, here's the question. So at a certain university, employees are annually rated from 1 to 4 on their productivity, with 1 being the least productive and 4 being the most productive. In a certain department at this certain university in a certain year, the number of employees receiving each rating from 1 to 4 are given here by these counts. Okay? So we want to compute the log cumulative odds for each rating. Okay, so remember that the odds are given by, so if we have just 2 possibilities, yes or no, or something like that, then the odds are given by p over 1 minus p, where p is the probability of something happening. And so the log odds is just the log of those odds. Okay? And so the cumulative log odds are very similar, but instead of using these probabilities for 2 possibilities, we're using the cumulative probabilities. So I'll talk about that in a second. And we can generalize this over however many ordered categories we want. Instead of just 2, we can go all the way up to m categories. Okay, so the log of the cumulative odds might look something like this. Okay, where k is one particular category, so the probability of a particular category, and the cumulative probability then for category k is the sum of probabilities 1 through k, where I is ordered such that 1 is less than 2 is less than 3, all the way up to less than m, where m is the max. Okay. So what we want to find is the log cumulative odds here, or that's what we're asked to find. Okay. So I've done this in kind of a extended way. There's much shorter ways of doing this, but I just thought I'd delineate each step. So we have the numbers, the number of rating 1, the number of rating 2, 3, 4. Okay. And so then I put all of those into a vector. Okay, 1s, 2s, 3s, 4s. So that will just give us back 12, 36, 7, 41. Then I take the probabilities of each of these, okay, which is just the number. So 12 for 1s divided by the sum of that vector. Okay. So then that gives us the probability of 2s and the probabilities of 3s and the probabilities of 4s. In fact, let's maybe I'll show these as we go along, right? So there's our score counts. Now then the probability of our score counts for 1, so 12.5% had a 1, 37.5% had a 2, 7.3% had a 3, and so on. Okay. So now if I want the cumulative probabilities, then I just need to sum up each of these, right? So for 1, the cumulative probability is just going to be that. For 2, it's going to be this plus this. For 3s, it's going to be this plus this plus this. Okay, so I just use the cum sum function there, right? Okay, so you notice it goes from 12.5%. I add the 2s, I add the 3s, and once I have all of them added up together, I get 1. Okay, and so now if I want the odds, well then I just want to take each of these divided by 1 minus that particular thing. Okay, so if I want the odds of each of these, okay, so here's my odds. Okay, and then if I want the log odds, obviously I just take the log of that. Okay, so these are our log odds. Okay, for the different scores, I'll just print all that out. And that's the end of 12M1. And now in 12M2, we want to make a figure of all of these that is represented in figure 12.5 in the book. Okay, and so let me just show you the plot here first. Okay, so and then we'll maybe walk through the code and then show you a better way of doing the code. This was just me trying to get a handle on how to do it. So so we have our different possible scores here, our different ratings, 1, 2, 3, 4, and so now the black line up to the empty spot or point, okay, that is the cumulative probability for each of these, okay, And then the blue line is the non-cumulative probability for each of these, right? So for number 1 here, the blue line and the black line, the probability and the cumulative probability are equal, okay? And then for 2s, right, the cumulative probability is the probability found in 1 plus the probability in 2, so that's the black line. And you see that the blue line truncates where the other blue line, or I'm sorry, where the other black line left off, okay? And then similarly for 3s, and then for 4s, okay? So the code here is, you know, first I just plot. In fact, maybe I'll just do these one at a time. So first I get the dots on there, okay? And then I have a command for the line. So maybe can I just run these 2 lines? We'll see what that does. Yeah, right. So so this first line's command and then the second line's command. The first line command gives me the black bar and then the blue bar, right? Cumulative and then non-cumulative probability. And then I just do that for each of the different categories. Okay, but we should probably loop over this. So here's that. This will generate the same plot, but you can see how abbreviated it is. So again, I start with just my plot here, right? That gives me the points. And then I have 4 categories, and for each of these categories, I want to put in 2 lines. One being the cumulative probability right here. Okay, so that will always start at 0, and then go up to the cumulative probability for I, you know, whatever I is, 1 through 4. And then I want to make the blue line, so I want to shift it over a little bit. So I take my my x coordinates. So this is x coordinates, this is y coordinates, right? And so I'm going to have 2 x coordinates, one at the bottom, one at the top, and they're the same, okay? And then 2 y coordinates, one at the bottom, one at the top, okay? So here I have my my blue line. So again, I want my x coordinates, okay, which is just going to be 1, 2, 3, or 4 plus a little bit, just to shift it away from the black line, okay? And then my y coordinates are going to be my cumulative probability, so the top of the black line, minus the non-cumulative probability, right? And that's where I get these gaps on the bottom here, okay? And then I'll color that blue. And so when I run all of that, I get the same plot. Okay, we'll call that good.